Hi, welcome to MACSGATE. In DBMS, today we are going to start a new chapter which is called Normalization. So let us start the session. What is normalization or why we need normalization? So let us start it. What is a normalization? The simple answer is it is a database design technique. When we design a database, this is one of the techniques we need to follow. So the simple answer for the question, what is normalization? It is a database design technique. Then why we need, or what is the purpose of this technique? The purpose of this technique. What is the purpose of this technique? This technique is mainly used to eliminate redundancy. Then what is the next question, sir? What is redundancy? What is redundancy? Duplication of data, or a data is stored multiple number of times. So what is redundancy? In simple words, it is duplication of data. Then if we are having duplicates of data, or if we are having redundancy in data, what is the problem, or why we need to eliminate redundancy? So we need to understand the problems of the redundancy. When we have redundancy in our database, what are the problems we face with redundancy? The first simple answer is wastage of memory. When we save the same data for multiple number of times, memory will be wasted. Then you may feel that, suppose, sir, I have so much memory in my laptop, then I don't want to worry about this wastage of memory. Is there any other problem which I need to consider? Yes. The main problems are anomalies when we update the database. What are the anomalies? When we insert a particular record, there are some problems which may arise because of this redundancy. So anomalies, in simple English, it is problems. The problems which might occur when we insert a record in the database. Similarly, in the database, we mainly do three major operations. The first one is insertion of a record. The second one is deletion. When we delete a particular record, what are the problems we might face in our database? Similarly, updation. So when we update the records, or when we modify, instead of updation, we can say modified. When we modify, some problems might rise. So we need to discuss what are these problems. Why we need normalization, sir? The simple answer is to eliminate redundancy. Why we need to eliminate redundancy? Because we have problems. What are the problems? The simple one is wastage of memory. If we have more memory, then no need to concern about this reason. But there are some problems which we need to consider compulsorily. What are those problems? Anomalies. When we insert a record in the database, and when we delete a record in the database, and when we update or modify a record, some problems might be erased. We need to consider those problems. So let us discuss these anomalies with a small example. So why we need normalization? The simple answer is to eliminate redundancy. To eliminate redundancy. If I don't eliminate redundancy, what are the problems? Let us discuss with an example. Suppose we have a table in which we are storing the details of the students and the courses what they registered in our college. So the details of the students and the courses what they registered in their BTech or MTech. Okay. So let us consider the attributes SID, student ID, and name of the student, age of the student, course name, what is the course he registered. Now the first point we need to observe is a student can register more than one course. That's the first point. A student can register more than one course. The second point, a course can be registered by so many students. In this example, please observe it. Whenever I consider the student whose ID is 22, what are the courses he registered? He registered DBMS. Any other course? Yes. He registered DS. My intention is data structures. Okay. Similarly, suppose I have taken the student 11. He also registered DBMS and DS. Suppose I taken the third student. He registered only one course, that is DBMS. So the first point is a student may register more than one course. The second point, a course can be registered by so many students. For example, suppose I consider the course DBMS. Who are the students who registered this DBMS? Of course, all the students in this particular instance registered DBMS. Similarly, what about data structures? Two students has registered. So this is, in this case, we stored the details of student as the course details of DBMS. Registered are stored for so many times. How many times we stored, sir? 3 times. So the same data is stored multiple copies. That is an example of a redundancy. That is an example of a redundancy. Then what are the problems? Right? So let me explain each of the problems one by one. Let us consider the first problem, insertion. Let us consider the problem insertion. Suppose our college wants to introduce a new course. Our college wants to introduce a new course. So we want to insert or we want to introduce a new course, machine learning. We want to introduce a new course, machine learning. So the HOD or the college authority has decided it. Now I want to store the details of machine learning in this particular table. To store the details of machine learning, I need the course name that I already have. I need the instructor. Suppose Sudhakar is the instructor and I need the credits. Let us suppose the credits are 4. So in generally, these are the details related to the particular course. But if we consider this table, to insert this course, compulsorily I need at least one student. I need at least one student. If I don't have at least one student, it's not possible to insert this record in this particular table. So here Sudhakar 4. Of course, we can have null values in these places, but according to this table schema, to insert a new course, I need to have at least one student in my database. Otherwise, it seems to be not correct. Is that clear, sir? So this is the problem we might face when we insert a record in the database. Let us consider the second one. Suppose we are doing deletion operation. We are doing deletion operation. For example, suppose I want to delete two students. I want to delete two students. For example, 11, 22. 11, 22. So these students has left our institute. So 11, 22. I need to strike out this row, and this row. So after deletion of these four rows, I have only one row in my database. That is not a problem at all. But the problem is, please observe it. When you delete these rows, unintentionally we lost the details of data structure. Where is the details of data structure, sir? In the resultant database, I have only the details of DBMS codes. But where is the details of data structure? We lost it. Hope you understood it. So the meaning is like this. When all the students who registered a particular course were left the institute, there is a chance of losing the details of the particular course also. So that is the problem we face when we delete the records. Let me explain the third one. Updation. So when we update a record, there might be some problem. Okay. For example, suppose I want to update the age. I want to update the age of students whose course name is DBMS. Whose course name equal to DBMS. Okay. Let us assume I want to update the age as 44. So I want to update the age of a student whose course name is DBMS. So then what will happen, sir? In the first row, it will be updated as 44. Even in the second row, it will be updated as 44. Even in the fourth row, it will be updated as 44. Am I clear, sir? Actually, we are supposed to update the age of a particular student depending on the student details, not on the details of the course in which he registered. But this is the wrong what we have done in this case. Okay, or this is the mistake we have done this. So then please observe it. In the first row, it is saying that the age of the student 22. The age of the student 22. NSR is 44. But in the same table, if we go to the last row, the age of the student, it is saying 40. So this leads to a problem of inconsistency. Which age I need to consider for the particular student NSR. Hope you understood it. So why we need normalization? Mainly to eliminate redundancy. If you don't eliminate redundancy, what are the problems? The problems we arise is insertion anomalies. Similarly, delete anomalies. And the next one is update anomalies. Right? So this is about normalization. To apply the technique of normalization, compulsorily we need to know what is a functional dependency. Without knowing the functional dependency or without having good experience in functional dependencies, it is not possible to apply normalization techniques. So compulsorily we need to know functional dependency. Then only we can do the normalization techniques very well. So in this session, we are mainly focusing on what is a functional dependency. What is a functional dependency, or how to identify what are the functional dependencies that will hold in our database. So what is a functional dependency? Let me give a practical example or the real-time example which every one of us knows. Suppose about a particular person, we know Aadhaar number, name, age, PAN card number, date of birth, and PIN code and the city in which he is living. So these are the details of the table which we manage in our database. Right, sir? Now listen to me. For example, suppose I know the PAN card of a particular candidate. I know PAN card of a particular candidate. Now the question is, with the help of PAN card, what are the other details we can get? With the help of PAN card, what you can get, sir? Date of birth. Am I right, sir? So with the help of PAN card, we can get date of birth. With the help of PAN card, can we get the name? Yes, of course, we can get it. Am I right, sir? So we can. So these are the two examples of the functional dependencies. Of course, with the help of PAN card, we may get some other details. Okay, as of now, let us assume these are the two details we can get using PAN card. Let me give one more example. Suppose I know PIN code of a particular candidate. I know PIN code. PIN code in the sense, PIN code of the address in which the particular candidate is living. Whenever you know PIN code, can you find the city in which he is staying? Yes, of course, we can easily find it. This is one more example of a PAN card. Sorry, this is one more example of a functional dependency. Suppose I know date of birth of a particular candidate. I know date of birth of a particular candidate. Can you get the age of the particular candidate? Yes, of course. So these are the good examples of the functional dependencies in this example. Right? Now, let me give some more examples. Suppose I know date of birth of a particular candidate. I know date of birth of a particular candidate. Can you write his name? Can you write his name? Functional dependence. Am I right, sir? Suppose I know name of a particular candidate. Can you write the age of a particular candidate? It's not possible. Sudhakar may have age 44 and there may be one more person, Sudhakar, with age 22. So this is also not possible. Hope you understood what is the meaning of functional dependency. Am I clear, sir? So whenever I know some attributes of a particular candidate, suppose I know the value of an attribute X about a particular candidate, then I can find the values of the attributes Y also. I can find the values of attributes of Y. Here, what are X, Y, and Z? These are the attribute sets. Attribute subsets. For example, in this case, instead of writing the first two functional dependencies separately, whenever I know PAN card, I can find date of birth, I can find age, I can find name. Am I right, sir? So this is one example of a good functional dependency. I mean, this is one a good example of a functional dependency. In this case, this is my X, this is my Y. What are these are? These two are subsets of the attribute sets. Is that clear? Now the question is, this is the example which every one of us are familiar. That means we know about what is Aadhaar, what is name, what is age. Now the question is, if you go to some real-time database, then even we cannot pronounce the attribute name in that particular table. They may give something like XYZ104. Then what is the meaning of it? I don't know. Whenever we don't have domain knowledge in that particular database, how to identify the functional dependencies? That's the question. So this is the main question, sir. Whenever we don't have domain knowledge, how to identify functional dependencies? How to identify the functional dependencies? Is the question clear, sir? In this example, it's very good. Sometimes we don't know about anything, the attributes of the particular relation, then how to identify it. Fine. So to identify the functional dependencies, how? How to identify functional dependencies? Okay, that is the question. Suppose I have a table or I have a relation in which I have some attributes A, B, C, D, E. Okay, and this process is applicable whenever I have some data, whenever I have some data in the table. That is, whenever we know the relation instance, whenever we know the data which is stored in that particular table, then only it is applicable. Okay, because in this example I don't know what is the meaning of A, what is the meaning of B, and similarly about the remaining attributes. Now the question is how to identify the functional dependencies. Fine. Suppose let us concentrate on the column B. Let us concentrate on the item B, and I want to verify whether B goes to D is valid or not. I want to verify a functional dependency in which B goes to D is valid or not. For that, the first one is we need to verify whether all values are unique or not. This is the first point we need to verify, whether all values of the particular column B are unique or not. Suppose I have the values of 10, 20, 30. Then whenever all the values are unique, that means I have only 3 rows in which the values of B are 10, 20, 30. When all the values are unique, then B implies any attribute. B implies any attribute. That means when the particular column don't have any duplicates, when the particular column don't have any duplicates, then B implies any one of the other attributes. So I can say B implies D is valid. Not only B implies D, sir. You can write B implies E, B implies A, anything. Fine. Now let us consider the second case. This is the case 1, sir. When all the values of the particular column are unique. Suppose I have case 2. What is the case? Suppose there are duplicates. Suppose there are duplicates. For example, let us consider the same table A, B, C, D. I need to verify whether D is having same value. For example, here I have 15, here also I have 15. That means whenever there is a duplicate here, and I want to verify X goes to Y or not. X goes to Y or not. Then if there are any 2 rows in which X values are same, there are any 2 rows, so instead of rows you can say tuples. When there are any 2 tuples in which the values of X are same, then compulsorily we need to have same values in the rows of Y also. So how we can write mathematically, sir? If T1 of X is equal to T2 of X, that means there are Yeah. Suppose if there are two tuples in which T1 of x is equal to T2 of x, then I need to have T1 of y is equal to T2 of y. Hope you understood it. So this is how we need to have. When there are two tuples in which the values of x are same, I need to have same values for the y column also. Hope you understood the definition of functional dependency. Please go through it, sir. Shall we continue? So, what are the types of functional dependencies? First, let me classify the types of functional dependencies. Then we go how to verify the functional dependencies. So, in functional dependencies, these are mainly classified into three types. The first one is trivial. The second one is non-trivial. The third one is semi-trivial. Okay. Let me give one real-time example. Suppose let us consider the same thing. I know the Aadhaar, name, and age. Let us consider only three examples. First, let me explain what is trivial. Sir, suppose I know Aadhaar. I know Aadhaar number of a particular candidate. Can you get the details of Aadhaar, sir? Suppose, sir, when you know Aadhaar number, I can write Aadhaar number, right? Okay, that is trivial. Am I right? Suppose when you know Aadhaar number, if you write the name, then it seems to be surprise. How he got my name? He don't know the name of mine. Whenever I know Aadhaar, I can write his name. So that is not trivial. So when trivial means whenever I know Aadhaar, I can write Aadhaar. Of course, suppose I know the name comma age, the name comma age of a particular person. Then can we write names? Of course, we can write it. This is trivial. Something like I given four of my details to you. Something like my phone number, my mail ID, my name, my age. Then you are announcing my name. Then people don't surprise because you already know four of my details. That is an example of a trivial dependency. So whenever I have a functional dependency, x goes to y. If the right side is a subset of x, if the right side is a subset of the left, people don't surprise because it's a trivial functional dependency. But whenever the right side and the left side intersection is empty, that means whenever I know one particular detail about you and I got my details. For example, I know your phone number. I know your phone number. We can apply it. What are the functional dependencies which will hold on this particular database? Fine. So let us consider the first one. It goes to T. What is the first case, sir? I need to verify values of A are unique or not. Values of A are unique. Are they unique, sir? No, actually I have 5 tuples here. Let me write the numbers T1, T2, T3, T4, T5. Fine. Now, are the values of the attribute A are unique, sir? No. So case 1 is not applicable. Go to case 2. What is case 2, sir? Whenever there are two tuples in which the values of x are same, whenever this happens, I need to have the same values for by attribute also. So in this example, T1 comma T2, T1 comma T2, both are having 1. In those two rows, what is the value of B, sir? For first column, I have 1. For second row, I have 2. So they are distinct. So this will not hold. They need to have same value. Hope you understood it. Let us consider the system of B goes to A. Are they unique, sir? Not unique. Then what are the duplicates? I think T1 comma T3. These two are having 1. Then what are the corresponding values of A? 1 comma 2. Both are giving different values. So this will not also hold in this particular example. What about A goes to C? The same question. Values are not unique. Values not unique. Then let us consider the rows in which we have duplicates. So according to the given table, tuple 1 and tuple 2 both are having 1 comma 1. What are the corresponding values of C? 4, 4. That means the same values. 1 plus 4, 1 plus 4. That's it. So this is fine. So let us consider the second duplicate. So I think third row, fourth row, fifth row, in which I have 2, 2, 2. What are the corresponding values of C? 3, 3, 3. They are same. So this condition is satisfied. When there are two tuples with the same values, then the other attribute also will have same values. So this is the only functional dependency which will hold on this particular instance. Is that clear? Let us do one more example. So they have given 7 functional dependencies and we need to verify which of them are satisfied in the given relation instance. Let us consider one by one. The first one is A goes to B. Are they unique, sir? Let us give the number T1, T2, T3, T4, sorry, T5, T6. Now the first one is the values are not unique and there are duplicates. In tuple 1 and tuple 3, I have values A1, A1. What are the corresponding values of B? B1, B3. They are different values. Since they are different values, it will not hold. So this is not satisfied in the relation instance. Whenever it was not satisfied for a particular duplicate, no need to verify for the remaining duplicates, right? So let's go to the second one. A goes to C. So let's consider the same tuples because the outside is same. A1, A1. What are the values of C, sir? We have C1, C1. When they are having same values, we should not say yes, it is holding. Consider other rows in which there are duplicates. So this is fine. And any other duplicates? A2, A2, A2. Yeah, I have T2, T4, T6. Now all these three tuples, I have A2, A2, A2. So what are the corresponding values? B2, B2, B2. All are giving same values. So the condition is true for all the duplicate values. So we can say this functional dependency is satisfied in this particular relation. Is that clear? So similarly, we can verify the remaining. So let's continue the remaining. C goes to A, that is the top one. What about C, sir? Is there any duplicates? Yes. So let's write the numbers T1, T4, T5, T6. Fine. So I think T1 comma T3. Yes, these are having duplicates C1 comma C1. What are the values of A? A1, A1. Of course, there is only one duplicate value in that it is satisfied. So this also satisfies. What about fourth one? AB goes to C. First verify the values of AB. Sir, I have A1, B1, A2, B2, A1, B3, A2, B2. There are duplicates, sir. Please verify it. T2, T4, even T6. These are having same values. A2, B2, A2, B2, to B2. What is the corresponding value of C, sir? In T2, I have C2. In T4, I have C3. Anyway, no need to continue. This was failed. Right? So the fourth functional dependency is not satisfied. Am I right, sir? What about the next one? BC goes to A. What about BC, sir? Please verify. B1, C1, B2, C2, B2, C3. I think all the values are unique. Values are unique. So it will be satisfied. Like that, you can verify the remaining two options 6, 7 so that you can answer the given question. Hope you understood it. So to verify any functional dependency, what I supposed to do, sir? The first one is we need to verify whether values of X are unique or not. If unique, no issue, it will be satisfied. If not unique, then we need to consider the tuples. We need to consider the tuples in which X is having same value. In those two tuples or three tuples, we need to have same value for Y also. So these are the two conditions we need to verify for any given functional dependency. Hope you understood the process. So let us do one of the previous question on this concept. Consider the following relation instance and which of the following FDs are satisfied for the given relation instance. The same story, sir. So let us continue with option A. In option A, they given two functional dependencies. What is the first one? XY implies Z. Let us play T1, T2, T3. What about XY values, sir? Please verify 14, 15, 16, 32. All values are unique. Values are unique. So XY implies anything. So the first option is clear. What about the second functional dependency given in option A? Z goes to Y. What about Z? I think T1, T4. Both are having same value 2. What are the corresponding values of Y? Please verify all the values are unique. When all the values are unique, it will be satisfied. But I think we verified option C, right? Yeah. So of course, we can verify the option B and D in the same manner. So in this case, option you got the correct answer. We are doing practice of previous questions. So better to possible functional dependencies. That means whenever we have n number of attributes, suppose I have a relation or with n number of attributes. So the n value can be 2, 3, depends on that. So let us suppose I have a number of attributes. What is the number of possible functional dependencies? Sir, they may be whole or they may not be whole. I don't know. First of all, I need to know what is the number of possible functional dependencies. So what is the count of days, right? So for this example, or for this one, let us consider a simple example. Suppose I have a relation with only two attributes, right? Now I want to write a functional dependency x goes to y. Now the question is, what is the condition on x comma y, sir? X comma y are attribute subsets. Are attribute sets. That means x is subset of a comma b and y is subset of a comma b. So x can be any subset of a comma b, y can be any subset of a comma b. So that means, let me write some of the examples. On left side x, I can have subset a. On right side I can write empty. On left side I can have a. On right side I can write b. Similarly, on left side I write b. On right side I write ab. Like that we can write. So that means on left side you can write any subset of a, on right side you can write any subset of this one. So now the question is, how many functional dependencies you can write? X can be any one of four subsets. X can be any one of four subsets. Whatever ways are, say any one of four subsets. Now, how many you can write, sir? Whenever I have two elements, how many subsets you can write? 2 power 2, which is 4. So X is having 4 possibilities. Similarly, Y is also having 4 possibilities. So the total number of possibilities will be 4 into 4, which is equal to 16. So this is the case when I have two attributes in the given relation. Now the thing is x comma y, and let us assume the case n number of attributes. Whenever I have n number of attributes, on the left side I can write any subset of attribute set. That means any subset of a set with n elements. For a set with n elements, how many subsets are possible? 2 power n. What about y? 2 power n. So totally it will be 2 power n into 2 power n. Am I clear, sir? So this is the total number of possible functional dependencies. For example, suppose n equal to 6. In this case, what will happen, sir? X can be any subset of a 6 element set. So the possibilities will be 2 power 6. Y can be also 2 power 6. What is the total number of possibilities? 2 power 6 into 2 power 6. Right? So I think 2 power 6 means 2, 4, 8, 16, 32. 64 into 64. So you can count the number, sir. I'm not writing it. Fine. So this is about possible functional dependencies. Out of these possible functional dependencies, some may be whole on the given instance. Some may not be satisfied. Hope you understood it. So this is one of the recent questions from 2024 paper, sir. Let's solve it. Just let us go through the question. A functional dependency f of x to y is termed as useful functional dependency. That means they are given a property useful. When it is useful, sir, if it is satisfying these three conditions. What are the three conditions? X must be non-empty. X must be non-empty. That means on the left side, I should not write empty set. I should not write empty set. Y must be non-empty. Even on the right side, I should not write non-empty set. The next one, intersection of x comma y must be empty set. They should not have any common elements. Am I clear, sir? So first, let me explain with small example. Then we go for counting. Right? Suppose we have the relation with 3. Or let us consider for simplicity only 2. What are the possible values for X? Empty set A, B, AB. Similarly, what are the possible values of Y? Empty A, B, A. So in general, it will be 2 power 2 into 2 power 2. Totally, it will be 4 into 4, 16. But out of these, they are given some conditions. What are the conditions? The first condition, X should not be empty. Y should not be empty. So I have only these possibilities. That means the left is having only 3 possibilities, the right side is having only 3 possibilities. It's totally 9. Then what about third conditions are? Intersection must be non-empty. That means suppose I have the left side as A. On the right side, I should not write A comma B. Because what is the intersection of these two? A. So the functional dependency should not have any common element. This is the story, sir. Am I clear in this? So this one we need to continue. And in this case, they given 4 attributes. In this case, they given 4 attributes. So let us count the number of this type of functional dependencies. Fine. So X goes to Y is the functional dependency, and let us assume this is the relation with 4 attributes are A, B, C, D. So before going to the first detail, for X, in general, we write 2 power 4 possibilities. But out of 2 power 4, empty should not be used. Empty should not be used. So what are the remaining possibilities? 2 power 4 minus 1. That means only 15 possibilities. Similarly, for Y, the same concept. Out of 2 power 4, I should not use empty set. That means I can use only 15 possibilities. Fine. Now we need to calculate the third condition. Depending on the third condition, X intersection Y equal to empty. So first let us consider the first one. For X, the left can be empty set, but according to the first condition, this we should not consider. Condition 1 will eliminate this. So let us consider the second one. That means I am considering the left side subsets. Depending on the left side subsets, we will count the number of functional dependencies. Now, for left side, suppose I have only one attribute. On left side, suppose I have only one attribute here. Then on right side, what you can write, sir? Right side, empty is not allowed. Fine. A also we should not write because A already used on left side. So here empty should not be used. A should not be used. What are the remaining values you can write? B, C, D. You can write any one of these 3 or any combination of these 3. So you can write any subset of this B, C, D. On the right side, correct any subset of B, C, D. Why you are considering only B, C, D, sir? Because A I should not use, right? So what are the possible subsets for this? 2 power 3, because the number of elements are 3. So the total number of subsets is 2 power 3. But among these 2 power 3, empty will be there. This I should not use. So I need to consider only 7 to power 3 minus 1. So anyway, since it is only 3 elements, let me list out. B you can write, C you can write, BCD, and BC, BD, CD, BCD. These are the 7 possible values for Y. Hope you understood it. So the conclusion is, whenever I have only one attribute on left side, for Y, how many possibles are? 7 possibilities. Am I clear, sir? So let me conclude this. So whenever I have left side A, what is the number of functional dependencies? 7 elements. The same will happen whenever I have B. So 7 elements. Similarly for C, similarly for D. Is that clear, sir? So this is when the left side is having only one attribute. This one you can write in a pure mathematical form. On left side, out of 4, I need to select one attribute. That is the left side possibilities 4C1. For each possibilities, how many we have? 7. So this is 4C1 into 7. Now let us consider the case in which I have 2 attributes on the left side. So x goes to y. This time I want to write 2. Let us suppose I have written a comma. So these 2 I should not use on the right side. Then what else you can use, sir? You can use anything. C comma D. So any subset of C comma D. How many possibilities are there, sir? 2 power 4. Out of 2 power 4, I should not use empty set. So how many left? 3. So for 2 element set, how many are possible, sir? 3. Like that, for left side, how many you can write? Out of 4, I want to select 2 elements, 4C2 into 3. Or if you want, you can list this one also, sir. On left side, I can write AB, AC, AD, BC, BD, CD. Total is 6. 6 is nothing but 4C2. 4C2 into 3. Hope you understood it. So this is the case when the left side is having 2 values. Like that, we can calculate the third one. What is the third one? The left side is having 3 values. When the left side is having 3 values, on right side, what you can have, sir? You can have whenever I have one element, what are the possible subset? Empty comma itself. Empty I should not write. So I can write 1. Right? So then for left side, out of 4, I need 3 elements. 4C3 into 1. Or you can store all the 4. A, B, C. A, B, D. A, C, D. B, C, D. So this is about whenever I have 3 elements. What about whenever I have 4 elements? A, B, C, D. Can you use any attribute? No. So this is 0. What is the total answer, sir? The first one, whenever I have one element on left side, what is the possibility is 4C1 into 7. The second one, 4C2 into 3. The third one, 4C3 into 1. Let us calculate it. 4 into 7, 28. 6 into 3, which is equal to 18. 4 into 1, which is equal to 4. I think this is 36, 26, 36. Sorry, 36, 46, 50. So this is the number of functional dependencies. What is the answer for this question, sir? 50. Hope you understood it. Is that clear, sir? So uses of functional dependencies. Fine. So I think we can continue the uses of functional dependencies in next session. Hope you enjoyed this session. Thank you.